Good morning, grade 12. This is Mrs. Pascale. Today's lesson is indefinite integrals. The objective is to calculate indefinite integrals using substitution method. Before we start for today, I need you please to review the previous rules, then do the following question. The substitution rule of integration. All of the integrals we've done to this point have required direct application of rules. But now we will deal with more complicated examples containing product of two factors or even division of two factors. As you notice in the example, integral 3x squared into x cubed minus 2 to the power 5 dx, we cannot rewrite this expression in another form, or we cannot even distribute it to get a sum of terms. So in such cases, we need to change the variable and use the substitution rule. The main concept of the substitution rule is to change the variable over which we are discussing the integration. So we need to take a supposition for the highest power of the expression, highest factor. In this one, we will take u is equal x cubed minus 2. Then we need to calculate the derivative of the new variable. So derivative over u is equal 3x squared derivative over x. Then we need to replace both u and du by their values, and we get u to the power 5 du. The parenthesis x cubed minus 2 represents u, and 3x squared dx represents du. Now we can calculate the integral since it's in the form of u to the power n du. It gives u 6 over 6 plus c. And finally, we need to rewrite the value of the integral or the answer of the integral in its initial variable. So we write x cubed minus 2 to the power 6 over 6 plus c. Let's take some examples. Example 1. Integral of 8x minus 12 into 4x squared minus 12x to the power 4 dx. Since we cannot distribute the following expression, so directly we need to think about the substitution method. What do we need to do at first step? We need to take the highest power and change its variable. So suppose u is equal 4x squared minus 12x. Next, we need to do the derivative of this new expression. So du is equal 8x minus 12 dx. Then replace the new variables in the integral. We get integral of u4 du. And finally, we can now calculate the integration since we can directly apply the rule of powers, and we get u5 over 5 plus c. And as the final answer, we need to give it in terms of x. So again, we replace u by its value in terms of x, and we get 4x squared minus 12x to the power 5 over 5 plus c. Example 2. If we need to calculate the integral of 3x squared 4th root of x cubed plus 5 dx, Again, this form cannot be simplified, so we need to take a supposition for the highest degree expression. Let u is equal to x cubed plus 5. Then we need to find its derivative. So du is equal 3x squared dx. Replacing u and du in the integral, we get u to the power 1 over 4 du. Then applying the rule, we get u to the power 5 over 4 over 5 over 4 plus c. Reducing the final answer, we get 4 over 5 into x cubed plus 5 to the power 5 over 4 plus c. Example 3, if we have the if we need to calculate the integral of 8x e to the power 4x squared dx, we need to take the supposition u is equal 4x squared. Then step 2, do the derivative over 4x squared, it's 8x. Step 3, replacing by the new variables u and du, we get eu du. So the final answer is equal eu plus c. And as we need to give our answer in terms of x, at the last step, replace u by the expression in terms of x, we get e to the power 4x squared plus c. Example 4, if we need to calculate the integral of 2x plus 1 e of exponent x squared plus x dx, suppose u is equal x squared plus x, then du is equal to x plus 1. Replacing u and du in the given integral, we get integral of eu du. Its answer is eu plus c. Finally, we need to replace u by the expression in terms of x. We get the answer e to the power x squared plus x plus c.